All right, just a reminder, your test is on Monday. It'll be about like 10 questions-ish, super similar to the review. So make sure you know how to do everything on the review, you'll do fine on the test. So I'm going to do one from each, since there's like 2 of each types of questions, but I'll just do one. So let's take a look at number 1. You need to find the standard form of the equation of a circle with the given information. So first thing we want to do is write our formula for a circle. So that is x minus h squared plus y minus k squared is equal to r squared. Our center is h comma k. So there's our h and our k. And then it gives us a point on the circle, so we could say this is x and y. And we're going to have to solve for r. So we want to plug in what we have and solve for our r. So x is 5 minus h, which is 3. Y is 5 minus negative 2, so that becomes a plus 2. And that's equal to r squared. 5 minus 3 is 2, so 2 squared, plus 5 plus 2 is 7, so 7 squared is equal to r squared. So it'd be 4 plus 49 is equal to r squared, so 53 is our r squared. We can find out what r is just by taking the square root, but in our equation we have r squared. So you really don't need to take the square root because we're just plugging in r squared. Like if you take the square root, you'll end up squaring it again. So it doesn't really matter. So we just want to plug in our h and k and our r squared. So we have x minus h squared plus y minus k, so y plus 2. Squared, and that's equal to r squared, which is 53. All right, let's take a look at number 3. Find the x and y intercepts. For our x-intercept, we need y to be equal to 0. For our y-intercept, we set x equal to 0. So let's find our y-intercept first. We have x plus 7 squared plus 0 minus 3 squared is equal to 5. Then we just solve for x. Nothing super special here. So x plus 7 squared plus 0 minus 3 is negative 3, and negative 3 squared would be 9. We can subtract 9 on both sides. So x plus 7 squared is equal to negative 4. We take the square root of both sides. So x plus 7 is equal to, can we take the square root of a negative number? No, we'd get an imaginary number. And we don't want to deal with imaginary numbers we only care about real numbers here. So since this is an imaginary number, we have no x-intercept. So there is no x-intercept. So y-intercept, we plug in 0 for x. So we have 0 plus 7 squared plus y minus 3 squared is equal to 5. 0 plus 7 is 7. 7 squared is 49. Plus y minus 3 squared is equal to 5. Subtract 49 on both sides. Y minus 3 squared is equal to negative 44. Take the square root of both sides.
You get an imaginary number.
We get an imaginary number. So do we have a y-intercept? No. Nope. No y-intercept. Number 5, we want to write the equation of a circle in standard form and identify the center and radius. So whenever it gives us an equation like this, we want to group our x's together, group our y's together, move all of our constants to the other side. So we have x squared minus 16x. I'm going to leave a space for that number that's going to help me complete the square there. Then I have plus y squared plus 4y, and then I'm going to leave a space. And then that's equal to, and I'm going to move the 9 over, so negative 9. So let's complete the square. What number is going to go here? What's our b? So our b is negative 16, so negative 16 divided by 2 squared. It's always b over 2 squared. So negative 16 divided by 2 is negative 8. So we're putting a negative 8 here. What's going to go in our parentheses here? Awesome.
Negative 8.
X minus 8. And now I'm adding this to the left side, so I have to make sure I add it to the right side too. So I'm adding 64 here, because negative 8 squared is 64. So I have to add 64 on the right side of my equation as well. So we got to do the same thing. So what's going to go in our space here? 4 over 2.
4.
So 4 divided by 2 is 2. So we're putting in a 2 squared here. What's going to go in our parentheses down here? Y plus 2. And then we are adding 2 squared on this side, so we're adding 4. So we have to add 4 on the right side of our equation as well. So I'm going to add these 3 numbers together. Negative 9 plus 64 plus 4 would be 59. Yep. And this is our standard form. So once we complete the square, that's our standard form of our equation. We also want to identify the center. So what would our center be here?
8 and negative 2.
Awesome. So notice how in the center we flip the signs of our 8 and 2. Just flip them. Because it's always like x minus h and y minus k. So for all of them, circle, parabola, ellipse, you always flip the signs for the center. And then the last thing we have to do is identify the radius. So what would our radius be?
Would it be the square root of 59?
Awesome, square root of 59. Because 59 is r squared, so we just take the square root, and that's our radius. All right, next page. So now we're moving on to parabolas. One thing before we move on to parabolas, for circles, there was a question in the notes that said, like it gave you the endpoints of the diameter. So if we had a circle, it gave you the endpoints of the diameter. You'll have a question, you'll most likely have a question like this on the test. So just go back to your notes if you want to practice one like this. I'm sure there's one in the WebAssign as well. But if you have the endpoints of the diameter, you just find the center, and that's your h comma k. And then you can use one of the endpoints as your x and y, and then you solve for your r. So it's just like we did in number 1, but you kind of have to think a little bit to find your center. So again, you have one like that in the notes if you want to practice. So let's move on to parabolas. So it gives us our vertex and our directrix, and we have to find the standard form. So first thing we want to do is write our equation that we're going to use. But for parabolas, we have 4 different types of equations, so we want to see which way this is opening up to determine which equation we use. So let's do a quick little sketch of what our graph is. Our vertex is at negative 5, 6, so we go to the left, negative 5, and up 6. And then our directrix is at negative 2. So we go x is equal to negative 2, so right here. Our directrix is on the other side of the focus, so our graph is going to open this way. It opens away from the directrix. So we have a graph that's opening up to the left, so we're going to use our formula y minus k squared is equal to 4p times x minus h. It gives us our vertex, so that's our h comma k. And then the only other thing we need is our p. So remember, so how can we determine where our focus is? It's going to be somewhere over here, but how do we know what our distance from the vertex to the focus is? How do we find p? So remember, our distance from the vertex to the directrix is the same distance from the vertex to the focus. So we're at negative 5 here, and this was at negative 2, so we're 3 spaces away in here. So that means we're 3 spaces away over here. So the distance from our vertex to our focus is 3, but since we're opening up to the left on that formula sheet, it tells us that our p is negative, so it is negative 3. So again, p is the distance from the focus to the vertex, which is the same distance as the vertex to the directrix. So now we can just plug everything in. We have our h, k, and p. So we have y minus k, so y minus 6 squared is equal to 4 times negative 3 times x minus h. So x plus, because minus a negative would be plus 5. And we can just multiply these two together. So y minus 6 squared is equal to negative 12 times x plus 5. All right, let's look at number 9. We'd find the standard form, the vertex, focus, and directrix for the parabola. So we want to get this parabola into our standard form. So we see whichever one's squared, and we know we're going to have to complete the square with that term. So we see our y is squared. We're going to have to complete the square there. We want to move everything else to the other side. So we have y squared minus 6y. We're completing the square here. And then we move everything else over. So I'm going to subtract 4x on both sides and add 3. Now we complete the square. So what value is going to go here? Negative 6 over 2 squared. Negative 6 over 2 is negative 3. So it's negative 3 squared. What goes into my parentheses squared down here? Y minus 3. So we just take the y and the minus 3. And then I can't forget, since I'm adding this negative 3 squared on this side, I have to do the same thing on the other side. Negative 3 squared is positive 9, so I'm adding 9 here. I have to add 9 to the right side of my equation as well. So on the right side, I have negative 4x, 3 plus 9 would be 12. And then I always want to divide what my greatest common factor is on the right side of my equation too, so I can get that to look like my standard form. So I have y minus 3 squared is equal to, what can I divide out of negative 4x plus 12? Negative 4. So at negative 4, I'm dividing from both of these. 12 divided by negative 4 is negative 3. So this is my standard form. What would my vertex be?
3 and 3.
3 and 3. So my vertex comes from my h and k. Always with the y is my k, and always with the x is my h. Here they just happen to be the same number, but just wanted to point that out. Next, so that's our vertex. We have to find the focus. How would we find the focus here?
So it would be 3, and then you have to find p first.
We have to find p first. So in our equation, this negative 4 is 4 times p. So 4p is equal to negative 4. So whatever that number is out front, that's 4p. Like our standard form up here. 4p is that number that's getting multiplied out front. So 4p is equal to negative 4. So what would p be equal to? P is equal to negative 1. So negative 1 is our distance from the vertex to the focus. So if I drew my little graph here, vertex is at 3, 3. It's y squared, so I know it's going to either open left or right, and my p is negative, so that means it's going to open left. So it's going to open this way. My focus is 1 point from the vertex, so I'm just moving 1 space this way. So what would my coordinate point be here at my vertex? At my focus? Perfect. 2, 3. We're just moving 1 to the left. And then my directrix is the same distance away from the vertex that the focus is. So instead of going 1 to the left, we're going 1 to the right. And here's my directrix. So what would my directrix be? X equals 4. Awesome. Good job. So let's look at our ellipses. So we have to find the standard form with the given characteristics. So our foci is at 2, 1, and 10, 1. And the minor axis is the length of 16. So it always helps to just draw a quick little sketch of our graph. We're going to the right 2, and up 1, and then to the right 10, and up 1. So these are our 2 foci. Are we going to have a horizontal ellipse or a vertical ellipse? Horizontal ellipse. So that means our A is going to be under the x. So I'm going to write my equation here. X minus h squared. The a squared is under it because the a is always bigger, and if the bigger number is under the x, it's a horizontal ellipse. And our foci are on a horizontal line, so we know it's a horizontal ellipse. And then plus y minus k squared over b squared. It's going to be equal to 1, because all of our ellipses are always equal to 1. How can we find the center of our ellipse?
You can count the spaces in between.
Count the spaces in between. There's 8 spaces in between, so halfway would be 4. So I'm going to go to the right 4. 1, 2, 3, 4. That would put me at what point?
6,
Awesome. 6, 1. let's go back to the information that was given. It tells us our minor axis has a length of 16. Minor axis is the one that does not have the foci. So this length here is 16. This length. So it's 16, the whole thing, so that would mean I'm going 8 spaces up and 8 spaces down. But another way we could think about it is our major axis is 2 times A and our minor is 2 times B. So it tells us our minor axis length, so that's going to help us find B. So what would the length of B be? If our minor axis is 16, so 16 is equal to 2 times B? 8. So B is equal to 8. We need to find A and C also. C always comes from the foci. C is the distance from the center to the focus, so what's the length of C?
4.
4. And then now that we're only missing one, we can just plug these into our formula. So we have C squared is equal to A squared minus B squared. So 4 squared is equal to A squared minus 8 squared. 4 squared is 16. Eight squared is 64. Add 64 on both sides. So 80 is our A squared. Take square root. So A is equal to what? Square root of 80. Can we simplify that? 16 goes into 80. 5 times. So 16 and 5. Square root of 16 is 4, so we have 4 square root 5. So now we can just plug in everything we have. We really only need our h, k, a squared, and b squared. But we want to find the c to help us find our a here. So that's why we need to find c, because then we have to plug it into the equation. But in our standard form here, we only need h, k, a, and b. So let's plug everything we have in. We have x minus h, so what was our h? 6. Our h and k come from the center, so h and k. X minus 6 squared plus y minus h squared. And then what is our a squared? So a squared was 80, but a is the square root of 80. So you just got to be careful with that. So if you want to, always write a squared and then take the square root of it. You really only need to take the square root if you were plotting it, because you want to see like what the distance is, but for your test, you're not going to graph anything. So you could just leave it as a squared if it helps you, because you're just plugging in a squared and you're plugging in b squared. So a squared we said was 80. And what's our b squared? If our b is 8, what's b squared? 64. And that's our equation. Let's look at 12. So first thing we want to do is plot the points that it gives us. So we have 2, 1, and 6, 1. So we go to the right 2, up 1, go to the right 6, up 1. And then, is it a horizontal ellipse or a vertical ellipse?
Horizontal.
Horizontal. So that means a squared is going to go over under the x. So we have x minus h squared over a squared plus y minus k squared over b squared is equal to 1. What is our center?
You would have to
Count the distance. So we have 1, 2, 3, 4. 4 units in between our foci. So the half of 4 would be 2. So our middle is 2 spaces away here. So 1, 2. So this point, which
4,
would
1.
be 4, 1. So center is our H and our K. Now we want to use the rest of the information to find A, B, and C. So our major goes with A, so our major is 2A, and our minor is 2B. So it gives us our minor axis here, which is 16. So 16 is equal to 2B. So what's B equal to? 8. And then C comes from the distance between our focus and our center. So what's the distance between the center and the focus? 2. So C is equal to 2. So we can use add 64 on both sides. So 68 is equal to a squared, which we really only need to plug in our a squared, so we don't even need to find a, so we can just circle it here. So to plug in, you only need h, k, a, and b. We have h, k, a squared, and b, so we can find b squared. So let's go ahead and plug in everything we have. X minus h, what's our h? 4, so x minus 4 squared, plus y minus k, what's our k? 1. And then that's equal to 1, and then we can put in our denominators. What's a squared? 68, and what's b squared? 64. In the notes from yesterday, there was a page that was a cheat sheet on how to solve ellipses. It's especially useful with number 11 and 12. So, like, step by step, it explains how to do 11 and 12. So if you're ever working this out and you're like, what do I do next? Make sure you have that cheat sheet with you, or like however you can think about it. Maybe the explanation on the cheat sheet is not the exact steps that you do, but you guys can use your notes. So have that with you, or have some type of form of that with you, so you know, what do I do next? What do I need next? Let's do 12. This was 12, so there's two 12s. The next 12. So we have to find the standard form of the equation of the ellipse. So our ellipse equation is x minus h squared over a squared plus y minus k squared over b squared is equal to 1. So we want our equation to look like this. So that means we need to complete the square. So we want to put our y's together. 4y squared minus 8y. We'll leave a space to complete the square. And then we're going to put our x's together. So plus x squared plus 6x. I don't know why I did y first, but it doesn't really matter. You'll end up with the same thing.
And then we want to move the 3 to the other side, so I'm going to add 3. All right, step 1. Set it up. Any questions on what we just did? Okay, good. What do we need to put in here to complete the square?
Negative a over 2.
B over 2 squared. We always have to be careful though. We want our y to be like 1y. We don't want a coefficient in front of our y. So here, since we have 4y, we want to divide the 4 out from everything. So I'm going to divide this by 4, this by 4. We'll worry about that in the next step. So take out a 4 first. So we have y squared minus 2y. And then we're going to complete the square with this. Same thing, b over 2. What's our b here? Negative 2 over 2. Negative 2 over 2 is negative 1. So what goes into my parentheses squared down here? Y minus 1. And then I can't forget that I took that 4 out, so I just need that 4 out front there too. And then here, I have negative 1 squared, so I'm adding 1. But it is actually 4 times 1. So I'm adding 4 here. So I need to add 4 on the right side also. So don't forget, if you take something out, you need to multiply it to that number that you're adding to. So negative 1 squared is 1. I'm adding 1, but it's actually 4 times 1. So I'm adding 4, so I need to add 4 to the right side. So we completed the square with the y's. Let's do the same thing with the x's. It's already just x squared, so we don't need to take anything out here. Thank goodness. What's going to go in my space here? 6 divided by 2 squared. 6 divided by 2 is 3. So I have 3 squared. What goes in my parentheses? X plus 3 squared. Here, I'm adding a 3 squared, which is 9. So I'm adding 9. I need to add 9 on my right side too. So I have 4 times y minus 1 squared plus x plus 3 squared is equal to 3 plus 4 plus 9 is 16. So I want this to be equal to 1. An ellipse has to be equal to 1. So how can I change this 16 to be 1? Perfect. Divide by 16. So I divide everything by 16 and simplify where I can. So I have 4 over 16. I could divide 4 out from both of these, and I'm just left with 4 in my denominator. So I have y minus 1 squared over 4 plus x plus 3 squared over 16, and that's equal to 1. The question here just says find the standard form, so that is it. Yes. Any questions on this one? All right, we're going to do 13 also. So I'm going to put my x's together and put my y's together. It doesn't matter which one you do first. Like here I did y's first, which if your answer was x plus 3 squared over 16 plus y minus 1 squared over 4 is equal to 1, same thing. Both of these are right. Here I'm just going to put x first. So we have 9x squared plus 36x, and then I want to put my y's together. Y squared minus 10y. Leave a space to complete the square. And then I want to move this 52 to the other side, so I'm going to subtract the 52. Now is where I divide by 9. So I want to take this 9 out and then divide both these by 9. So I have 9 on the outside, and x squared plus 36 divided by 9 is 4. So 4x. What number am I going to put here to complete the square?
4/2 squared.
B over 2 squared, so 4 over 2 squared. This would be 2 squared. So what goes into my parentheses down here?
X plus 2.
X plus 2. I have to put the 9 in front. Thank you. I always forget that. And then I'm adding 2 squared here. So I'm adding 4, but it is actually 4 times 9. So I'm adding 36 in here. So I have to add 36 on the right side too. Any questions on what we just did with x? We're going to do the same thing with y. My y has a coefficient of 1, so I don't have to take anything out here. What's going to go into my space here?
-10 over 2 squared.
-10 over 2 squared. So -10 divided by 2 is -5. What goes into my parentheses here? Y minus 5. And then I'm adding -5 squared, so I'm adding 25 here. So I have to add 25 on my right side too. Be careful because even though this is negative, like I'm not subtracting it, you're always adding. So you'll always be adding whatever to the right side also. So that's a pretty common mistake. People think that like because it's negative that they're subtracting it on the left side, but you're not subtracting 25, you're adding 25 because it's -5 squared. But the negative is important because that negative has to go in there also. So we have plus y minus 5 squared, and that's equal to, got to add all of these together, -52 plus 36 plus 25. So 36 plus 25 would be 51. So this is -1. How can I get this to be equal to 1, not -1?
You divide by a negative.
Divide by a negative. So we're going to divide everything by -1. So I would have 9 times x plus 2 squared. This would be -9. It doesn't matter if you keep the negative on the top or the bottom. Minus y minus 5 squared divided by 1 is equal to 1. So it helps to leave the 1s on the bottom because standard form of a circle is like with a denominator over here. So it has a denominator, so it helps just to see that like 1 is your a squared and 1 is your b squared. So you don't have to leave it over 1, but kind of helps if you were graphing it. But again, we're not graphing. Let's look at 14. So given the equation of the ellipse in standard form, find the following. You guys are not going to have to find the eccentricity. Yeah, we skipped it in the notes, so you're not going to have to do that. So let us find the center. What would our center for 14 be? 0, 0. Next, we want to find our vertices. So it could help us to graph it, give it a little sketch here. Our center is at 0, 0. We have our bigger number under the x, so does that mean it is a horizontal ellipse or a vertical ellipse?
Horizontal.
Horizontal. So our bigger number A is the distance from the center to the vertice. So A squared is 25. What would A be? 5. So from our center to our vertex on the right side is 5. 1, 2, 3, 4, 5. And then same in the left direction. 1, 2, 3, 4, 5. And then B is the other number. And that is, B is the distance from our center to our vertex on the minor axis. So if B squared is 16, what is B? 4. So we're going to go 4 up and 4 down. Once you put your points there, you just look at the points and those are your vertices. So on the right side, what would our vertex here be? 5, 0, because we go to the right, 5. And then on the left, it would be the opposite, so negative 5, 0. What about the pink dots? 0, 4, and 0, -4. Perfect. And how can we find our foci? Remember, foci comes from that C. So if we have A and we have B, we can just use our formula to find C. So C squared is equal to A squared minus B squared. So C squared is equal to our A is 5. So 5 squared minus 4 squared. C squared would be 25 minus 16. So that would be 9. Awesome. Take the square root. So C is equal to 3. So 3 is our distance from our center to the foci. And foci are always on the major axis. So we're going 3 to the right and 3 to the left. So what are 2 points for our foci?
-3, 0, and 3, 0.
-3, 0, and 3, 0. Let's look at 15. So what would our center be?
-3, 5.
-3, 5. Always flip the signs. So let's put that on our graph. -3, 5. That is our center. Now the bigger number is under our Y, so is that going to be a horizontal ellipse or a vertical ellipse? Vertical. It will be vertical. So 25 is our A because the bigger number is always your A. So A squared is 25. What's A equal to? 5. So that means we're going to go in which direction? 5. Up and down. So we go up 5 and down 5. We do the same thing with our B. So B squared is 16. What's B? 4. So we go to the left and right 4. 1, 2, 3, 4. Now we just need to name the coordinates of each point. So our major vertices, we go to the left to -3, so they're both going to start with -3. And then we go up. We were at 5, we went up 5 more, so we're at 10. And the other one's -3. We went down 5, so 0. And then what about our minor vertices? What are those points going to be? The pink dots. we went to the right 1, so positive 1, and up 5. And then what about our other one? -7. What's our y? 5. So those are vertices.
Okay, I think it's -8.
We were at -3 and we went 4 more in the left direction, so -7.
Okay.
And then we want to find our foci. How can we find the foci? C squared is equal to a squared minus b squared. So c squared is equal to our a squared is 25 minus our b squared, which is 16. So c squared is equal to 9 again. So what's c? 3. So 3 is our distance from our foci to our center to our foci on the major axis. So do our foci go up and down or left and right? Up and down. So we go 3 up, 1, 2, 3, and 3 down. So since we started our x-coordinate for our foci, I'm going to put them over here. Our x-coordinate stays the same. We're at -3 for both of them. Our y-coordinate was 5, and we go up 3, so 5 plus 3 would be 8, and then 5 minus 3 would be 2.